I think it's the 29th. Okay, I'm ready. Yes, please, Bailey, go ahead.
2 to the 9x plus 1.
2
To the 9x plus 1.
9x plus 1, very good.
Equals
Yes,
5
yes.
to the x minus 9.
Excellent problem. What type of equation is this?
Exponential.
Very good, because the variable is at the exponent level. Excellent. Okay, can I make 2 and 5 with the same base? No. So my only chance is to apply the inverse function, which would be
Natural quotient.
either natural log or common log. Yes, very good. Thank you. So let's apply natural log. I prefer natural log unless the base is 10. If I have a base here, either 2 or 5 are 10, either 2 or 5 is 10, then I will apply LOG, common log. Otherwise, I'll never apply LOG. Why? Because I'm lazy. It's easier for me to write LN than LOG. It doesn't matter really. Okay, so now be very careful because 9x plus 1, if you do not put it in parentheses, you're already making an error. So the property of the property of the log, the power property is, I don't like to say exponential, but you know what I mean. The property, the power rule for log allows us to bring that number in front, but this becomes a factor. If you don't put parentheses, you're only considering only one as a factor, not the whole thing. So be careful with that. Now we have to distribute. So we get 9x natural log 2 plus natural log 2 equals x natural log 5 minus 9 natural log 5. That will be our next step. Now, do not get impressed by natural log 2 is just a number, or by natural log 5, just a number. So I see two terms have x in them, so I will have to move this term to this side and move natural log to the other, because I'm solving for x. So 9x natural log 2 minus x natural log 5 equals negative natural log 2 minus 9 natural log 5. Now on the left-hand side, I have to combine like terms, but I can't. You could say, oh, but if I multiply 9 by natural log 2 and I evaluate or approximate natural log 5, I can combine these. True, but you're not going to get an exact answer. And we are after the exact answer. So bottom line, you cannot combine them, but you can do something else, which is, of course, you factor out x, and 9 natural log 2 minus natural log 5 equals negative natural log 2 minus 9 natural log 5, and you're done by dividing. Of course, I would, especially on a test situation, at the end of the test, I would make a little star when I work on this problem. At the end of the test, if I have time, I'll go back and check, just to make sure. So of course, x would be that piece over this piece, which is the factor in front of x. So negative natural log 2 minus 9 natural log 5, 9 natural log 2 minus natural log 5. If you want to approximate it, let me know and I'll show you. I think we've done this before, but it doesn't matter. I can show you again. Baby, is this okay?
Yeah, I did it all right, but when I was looking on the example online, it just made it, I didn't really understand that you were supposed to distribute the 9x plus 1. And it kind of confused me on that, because I thought it was taking like the individual terms.
Yes, that's why I highly recommend you do the problems we do in class first. After you manage perfectly those, you are 10 steps ahead of everyone else. And you're not going to have any difficulties with the problems in WebAssign. But that's just my opinion. Yes, Vanessa, go ahead.
I have a question.
Yes. Yes.
Log base 2 square root of
So this is log base 2
square root 2.
of the square root of 2.
Yeah.
Okay. And that's it?
Yeah.
Okay. So we have no idea what this is. So we will be changing into 2 raised to which power equals the square root of 2. Because we know that any log equation, I just created a log equation, can be changed into an exponential one. And there is only one number that makes these two equal. What would that be?
Perhaps.
Perfect. How did you get that?
What is square root of 2?
So 2 raised to 1/2 is the square root of 2.
So the two combined.
Yes, Hunter, go ahead.
So this is more of a question about WebAssign.
Yes,
On 6.7,
Yes.
I asked a question last class period, and we got the right answer for the class for the problem, and we set the equation correctly. But in WebAssign, when I put in the equation, it wasn't taking my equation, and it didn't take my answer either.
do I know the problem?
Yes, it's the same one that we did in class on Thursday. And this is the equation we set up, and
Was the equation okay?
the equation is okay.
Okay, so
Oh,
it's,
no, in WebAssign the equation, they didn't put the equation.
it is an equation, so I'm not sure.
It was
Which question was it on?
6.7, it was like,
6.7, which number?
Was it just-
6.7, which number?
it was either 3 or 4, I didn't have the number. I didn't have it.
Was it the grams of iodine and stuff?
Would
Yeah, it was
you like to
one
log
that had
in?
0.2,
Would you like to log in here?
I guess.
Or do you have it? Huh? I'm sorry, Caleb?
Okay, yeah, I think both of these were similar. So
Okay.
what was?
So can you dictate or tell me what it is?
Yes.
Okay, I'm ready.
A tumor was injected with 0.6 grams of iodine, which has a decay rate of 1.15% per day.
How do we spell? Is it I-O? Yeah, that's what I thought.
Now, write an exponential model representing the number of grams.
So this is M of T. Did you put M instead of A or something like that?
They had F and T, so whatever.
Okay,
And then just that number remaining after T days.
okay, so can you read it one more time? So we inject this person with 0.6 grams of iodine. And then,
And then they want, so the rate is the decay rate.
yes,
1.15%,
okay, let me write that. So K equals 1.15%,
5.
and that is 0.0115.
Yes,
So M of T, so everything is in grams, correct?
Yeah.
Maybe, I'm just thinking that maybe there is a error in the measurement unit or
what
something.
they ended up doing,
So this is e to negative 0.0115 t.
yeah, I had a problem putting in that same equation, is that what you had a problem with too? Yeah, because what I did in the practice in the other
Did you put
version,
the multiplication symbol?
they didn't even do that kind of rate, they didn't have a negative K, they went straight to a natural
Yeah,
log
it's
or
like a
number.
natural log thing, it's weird.
So instead of doing, they didn't even have a 0.
They took
0.0115.
0.115, they subtracted from 1. They
Yeah.
got like, it's like 988 or something like that.
Yeah, they had, so their equation was 0.6 e to the natural log of 0.9885.
And they're doing something with natural log.
So for whatever reason, that actually isn't the same rate as the.
The one they give in the
So
problem.
those two equations are different. That's what they had. So you wanna see it? I have it pulled up. 4, see what they did there? And so when you put in that equation, they actually got it. Yeah. And the only way I figured that out, here, I'll show you how I did that job, I did practice another version. Because at first I didn't have the answer right, so I was like, insert.
But they are
insert.
giving us the K, so why?
I know, I don't know why they did that. So I just, you have to put an
Right, so
answer
this is
to it,
the
and then
model,
they
right?
show you that, right? So I was like, why did they have it as that? So I just took this number and I subtracted it from 1, and that's how you get the 0.9885, and then they put the natural log in there.
But they give you the model right
Right, I
here.
don't get it. I don't get it.
I will further investigate. I will further investigate. So I'll give you the point for that. I'll give you the point for that if you did this problem. I have no idea, because they do give in the explanation that's what the model is, that's the model they give.
Right.
And that's the decay model, the exponential decay model. So we'll figure out at the end of the class, so I don't spend too much time on this. Is that okay? Okay, perfect. Other questions for me? Yes, anything else?
Yeah, I'll do mine. Log base 2, 1 over 16,
1 over,
16
yes,
plus 9.
outside?
Yeah.
Plus 9?
Yeah.
Good. So first of all, we address log base 2 of 1 over 16. We have no idea what that is, but we know that this is equivalent to 2 to some power equals 1 over 16. And there is only one number that works, and that number would be negative 4.
What do we do to the math?
So this is negative 4. So this answer here is negative 4. Negative 4 plus 9 equals 5.
Wait, why wouldn't you put log, wait, is it because the log can equal negative numbers? Is that why you didn't put log base 2?
The answer is negative 4.
Then why didn't you just do log base 2, 1
That's
over
what
16
we're- that's what we're
equals
asked.
Negative 9.
89? Why didn't you subtract the
This is
9?
not an equation. We're asked to simplify. That 9 can wait. I have to simplify this first. So I simplified, it's negative 4, so this can be replaced by negative 4. Negative 4 plus 9 is 5.
2 terms.
Is that okay?
Yeah.
Perfect. Anything else?
I'm still thinking.
Anything else? Other questions? Okay, so now let's make a decision. Since we decided that test 3 will be on November 2 weeks from Thursday, so that's the 14th, correct? Okay. Now, what I would like your input on is what should this test cover? Of course, you will cover chapter 6. Of course, you will cover chapter 7. And I recommend also these sections from chapter 8 and 2 sections from chapter 10. Of course, the review will be November the 12th. So we don't have to make a decision today, but I'd like to plan ahead. So just think about it. So my idea is chapters 6, 7, 8, which is 3 sections, and 10, which is 2 sections. So chapter 6, 7, this is 4 sections. So chapter 6, 4 sections of chapter 7, 3 of chapter 8, and 2 of chapter 10. That's the idea. Let's see if we can accomplish that and how soon. And just keep that in mind that I need your input and see if this is okay with you. Okay?
And then we'll be having quizzes on these chapters as well.
Oh, we'll have a little quiz on Thursday. Yeah. Thursday, yes. Okay, ready? So let's go back. I wanted to go back to 7.1 for a second to explain what coterminal angles are. Coterminal angles. And you'll understand why this is so important. So for example, angle theta, let's say pi over 6, it's in the first quadrant. It's 30 degrees. In order to show it as accurately as possible, I divvy up the first quadrant into 3 equal pieces or approximately equal. And this will be pi over 6. This is the angle theta. Now, we can find coterminal angles, either positive or negative. What does coterminal mean? Same initial side and same terminal side. We can find infinitely many. Here's one. 360 or 2 pi plus pi over 6. Would you agree that theta and 2 pi plus theta are coterminal angles? Both start at the same initial, and they have the same initial side and they have the same terminal side. Obviously, they will also have all trig function values identical. Okay? So I'm going to say alpha equals 2 pi plus pi over 6, which means 13 pi over 6 is a positive coterminal angle with theta. Can anyone give us, let's say beta, a negative coterminal angle? If it's a negative coterminal, bless you, it has to start here and it has to end here, but it doesn't matter. You can go around the unit, around the circle as many times as you want. So here's one option. Yes, babe?
Negative 11/5/6.
So you have the 2 pi, and you subtract pi over 6. Exactly.
Negative 11.
Exactly, but negative. Perfect. So this will be 2 pi. I would say, because it's negative, right? So I'm going to say negative 2 pi and plus pi over 6, and that's exactly negative 11 pi over 6. So beta, which is negative 11 pi over 6, is a negative coterminal angle with theta. And of course, what is so special about coterminal angles? They will have
All the same property.
all the same trig function values. The same sine, the same cosine, the same tangent, the same secant, etc., etc., etc. So we can write that down. Coterminal angles have identical trig function values. They have identical trig function values. One other thing that I would like to look at here, and then we can move on. I don't see examples though, but I would like to just talk about it briefly. Here it is. Okay, if we drive on a straight line, we know that distance equals rate times time, right? Rate, distance, right? Distance equals rate times time if we drive on a straight line. Or if we go up and down a hill, but straight. But what happens when we go around a circle, or let's say a roundabout, or let's say a curve, right? We're getting off 95 at some point in time and we have to make a turn, right? So let's suppose we are driving between this point and this point in any direction, it doesn't matter. Now, there are two speeds here. There is something called the linear speed and also angular speed. The linear speed is still denoted by v, or velocity, but the angular speed is denoted by omega. This is another Greek letter. By omega. Like any speed, the rate or speed or velocity is distance over time. So remember we determined this, which is the length of the arc. We know that this is the radius, and we have the central angle theta in radians. So the linear speed is the distance divided by time. Distance being the arc length. The angular speed has something to do with the angle that we sweep, if you want, or we drive on. So this is theta divided by time.
Where's the W again?
Omega.
So then, okay, so
Yes, omega. Now there is also a relationship between these two. And here's the relationship. I'm going to solve the first equation, the linear speed for t. I'm going to solve this second one for t, and theta divided by omega. And I'm going to replace s, but what we know from last time, which is r times theta. So this is an equation that we just created by setting equal time from the first equation to time from the second one, and replacing now s by r theta over v equals theta over omega. Oops. I can simplify both sides. multiplying by 1 over theta. And this is the relationship between the two of them. And now I can cross multiply. V equals R times omega. The linear speed equals the radius of the circle times the angular speed.
Wait, can you do that again?
Which one? Which part?
Wait,
I solved this for t,
yeah, I got
which
it.
is s over v. I solved this for t, which is theta over omega. I replaced this from last time by r times theta. I copied v, I copied theta, I copied omega. I multiplied both sides by 1 over theta. The left-hand side is r over v. The right-hand side is 1 over omega. Now I cross multiply. V times 1 equals r times w.
So the arc length is the radius.
The arc length is the radius times the angle subtend. Yes, the central angle. Yes. Is this clear? I saw that. 1 second. Is this clear? Better? Yes. Vanessa, go ahead.
So how do we differentiate with what's angular speed and linear speed if it's given to us in the problem?
The linear speed does not depend on the angle. The angular speed depends on the angle.
So are you gonna give us?
If there is no angle, there is no angular speed. So if you're driving and you're not turning into any direction, you're driving straight, there is no angular speed. Very good. I'm trying to find something in here. A sector. I find it, okay, find the linear speed of the average. For some reason, I don't see any. Well, I'll find some examples for you for next time. Just remind me. I will not forget, but just remind me. Okay, so we talked about let me know if we need more. Say it again.
You make up a problem?
Not at the top of my head. Right this moment. I mean, I can. Yes. I mean, I can say. Sure. Why not? So let's say theta equals pi over 3. Let's say time is 1 hour. And we would like to determine the angular speed. So the angular speed, I wanted something more sophisticated for you, but a simple example, of course, I can make up. So the angular speed is theta divided by time. We have both. So then the angular speed will be pi divided by 3 divided by 1. So the angular speed is pi over 3. But the measurement unit is the most important. So as we know, a rate of change, which is the angular speed, it's a rate of change, has to have two measurement units. One coming from the top and one coming from the denominator. So this angular speed is pi over 3. And what is its measurement unit? It has to be a ratio. Yes, radians per hour, exactly. So please remember, like when I drive and you call me and you say, what is your speed? I'm not going to say I'm driving at 40 miles. I'm going to say I'm driving at 40 miles an hour. So this is the rate of change of the angle with respect to time. So that's why it's in radius per hour. Very good. I think we had enough examples, unless you want more examples on how to determine different measures of x. If we're done with that, we can move on. We did a couple of examples last time. Are we okay with that?
We do like one.
Okay, so let's do one more. Let's take a look. Any preference? I see here 44, 45. Last time we looked at 43 or 42, which are the same. So which one we want to look at now? We want to look at 45. Excellent. So this is on page 603, and here it is. So this is what we have. We have this leg, the measure of this leg of 119. We have the measure of this base angle of 70. We have the other one of 26, and we're asked to find x. There is nothing else given to us. Okay, so looking at this, I can determine easily these angles if I need them. No problem, right? Because this is 90 degrees and this is 70. This little one must be 20 degrees. And also this is 90 and this is 26. So this bigger one here must be 90 minus 26. So we can immediately determine those if we need to. Okay. Now, my idea is, or if you have any ideas, I'd like to listen to what you have in mind. My idea is to determine this, also to determine this. So therefore, when I determine A and B, I know that X will be for sure. Absolutely, A minus B, excellent. So now let's see if we can determine A from this triangle. I'm sorry, A from this triangle. I have the measure of the adjacent angle for this, or the opposite angle for this, but I don't have any information about the hypotenuse. So when I don't have any information about the hypotenuse, I will try to avoid anything that has the hypotenuse in it, right? Which is sine, cosine, secant, cosecant. So I'll try to stay with or think of tangent or cotangent. So if that's the case, I could use tangent of 26, which is the opposite over the adjacent. Let's see what happens now. Tangent 26 degrees is 119 divided by x plus b. I can also write, in a minute I'll come back, I can also write that tangent 70 degrees is 119 divided by b. Would you accept that? So I can change this. You can say, okay, well, but this is your A. Yeah, that's fine. It's my A. So from here, I will solve for A. Remember, this is cross multiplication. And I get A equals 119 over tangent 26. Same thing here. I get B equals 119 over tangent 70. And I'm pretty much done.
How did you get x plus b equals a there? Because you have x minus b. Or yeah, sorry, I have x equals a minus b. Oh, that's what you're trying to solve for?
So when I use tangent 26, I have the opposite leg over the adjacent leg. So I have 119 over A. Is that okay?
Yeah.
And then I have tangent 70, which is the opposite over the adjacent, which is 119 over B. From this relationship, I solve for A, which is 119 over tangent 26 degrees. And then I solve for B, 119 over tangent 70. And then all I have to do is copy 119 over tangent 26 degrees minus 119 over tangent 70 degrees, and I get an approximation for x. Now, please make sure that when you plug this in the graphing calculator, your mode is in degree mode, not in radians, because you're not going to get the correct answer otherwise. So you want me to determine this? Or you can determine it for me. No, I'm not lazy. I can do it. Okay. So here's how I would do it. I would put 119. Let me clear all this. 119. And in parentheses, tangent 26. I need another parenthesis because I don't trust this system. Okay, tangent 26 to power -1, or you can put cotangent if you want to be fancy. This is what, if it's even nicer. Minus, in parentheses, tangent 70. Close the parenthesis, put power -1 and close. But now I have to make sure I would have gotten something weird. that the mode is in degree mode, and now you can press enter. So I got 200.67. They're not giving us any measurement unit. Please tell me what you got when you determined this. Did anyone else get 200.67? Excellent. So this is how I would have done it, but of course you can use cotangent. However, there is no cotangent symbol in the graphing calculator, so that's why I chose that route, to put it like that. Okay. Here is something that I would like to show you. I completely disagree with this. You're not going to sit there and memorize this. I hope you're not going to do something like this. There's no need. There's no need. This is insane. I would have never done this. I wouldn't even, if I were to write a book, I would not even put it in like that. But it's up to you. Okay? So now, oops, the other way. Okay. So now we are looking at all sorts of types of problems. These are questions, but this is okay. This is fine. And then we can just follow through with different exercises from 7.3. 7.3, in 7.3 we just have to practice because we've done this last time. So it talks about the unit circle, finding the reference angle, which we already did, but we need to practice. That was not enough by any means. And using the reference angle to evaluate trig functions. We just did that, but let's, okay, and more types of problems before we start the graphs of sine and cosine. Okay, so I'm ready for your questions. So it says for the following exercises, find the exact value of each trig function. We're past that, but we can choose. For the following exercises, state the reference angle. We're past that, but we can choose. I'd like a combo of these. For the following exercises, find the reference angle, the quadrant, that's it, and the sine and cosine for each angle, and we will determine the other ones as well. So this is what I would like us to choose from. And then we can move on to, for the following exercise, use the given point on the unit circle to find the value of sine and cosine. So we'll do that too. Very simple. Okay, so I think we should start with a problem from here. Anything you'd like to start with? Anything?
30.
From 34 through 48. Which one?
36.
36 it is. So let's start. So 36 on page 617. Okay, 36 has 320 degrees. And it says, find the reference angle, the quadrant of the terminal side, and the sine and cosine for each angle. Okay, so first of all, I know that a complete rotation has 360 degrees, correct? So obviously, this is shy, what? 40 degrees. So that means that the angle is, first of all, it's a positive angle, and this is theta, 320 degrees. So we can say for now that its terminal side, it's a positive angle. Its terminal side is in the fourth quadrant. We can immediately say that sine is positive or negative.
Negative.
Yes, because remember sine is measured is the height, right? Is the opposite. So it's measured on the y-axis. So sine will be negative. So we're going to say positive angle. Positive cosine, negative sine.
So wouldn't that make that negative angle?
Terminal, one second. Terminal side in the fourth quadrant. Okay, so, and what is the reference angle?
40.
So reference angle equals 40 degrees. Very good. The reference angle is always positive? What did you ask? I'm sorry. That if it makes an angle negative?
Wait, you wrote positive angle. Okay,
Yes,
what were you
it is
referring to?
it is a positive angle. Otherwise, if it's a negative angle, then I have to do this.
Oh, you go the other direction, oh, okay.
Yes, the negative angle is in the clockwise. The positive angle is counterclockwise. Okay, so now we do not have a tool of determining this exactly. We have to use the calculator for such an angle. Let's determine, since it's in degrees, and my mode is still in degrees, yes, we can determine sine 40 degrees of the reference angle and cosine of 40 degrees, which is the reference angle. But when we put them down and write them in our notes, we have to say that sine 320 degrees is approximately negative 0.6428 if you want 4 decimal digits. And then cosine 320 degrees is approximately positive, you don't have to write the positive, I'm just making a point, 7660. Because any angle in the fourth quadrant will have a negative sign and a positive cosine. Okay, although it was a very good example, I'd like to choose one more. Let's look at one, yes, Bailey? Okay, so we want to look at 5 pi over 3, excellent. So, on the same page, theta equals 5 pi over 3. Now you could say, how will I know where this angle has its terminal side? No problem, because I know that this is 60 degrees, and I know exactly where it ends. It lands, right? So 5 times 60 is 300, so it's again in the fourth quadrant, but that's okay. So when we picture this, so since it's 300 degrees, it's 60 degrees shy of 360. So this is, again, it's a positive angle. Again, it will have a positive cosine and a negative sine. What is the reference angle this time? Yes, it is pi over 3. So here's how we write the answer for sine and cosine. Moving forward, sine of 5 pi over 3 equals the opposite of sine of the reference angle. The reference angle is 60 degrees, so sine of 60 degrees is positive. But this sine of 5 pi over 3 must be negative because its terminal side is in the fourth quadrant. For cosine, I write the same, but positive. So cosine 5 pi over 3 equals positive. You don't have to write the positive, I'm just making a point. And now I know that this is the largest, the third angle, the largest angle in the little table. So then I know that this must be the square root of 3 over 2, and this must be 1/2. It's the last at the bottom angle. So, of course, with a minus in front. So negative the square root of 3 over 2 and positive 1/2. That's how we determine sine and cosine. And it makes sense. Because remember how we define sine? The opposite leg over the hypotenuse. There is no opposite leg over hypotenuse in a 300-degree angle. It doesn't fit in any triangle. So you have to determine the reference angle. The reference angle is the one that fits in a right triangle. That's why we determine the reference angle. Yes, these are called periodic functions. You can take the calculator and plug in any angle, 5,000 degrees, and you will get sine for it. But that's not an angle that fits in a right triangle. So once you determine the reference angle, everything else falls into place. Okay, very good. I would like to look at the couple of very important trig identities here. So let's go back to, this is still 7.3 unit circle. Meaning the radius equals 1. Unit circle, the radius equals 1. Okay, let's suppose we have an angle, and that angle is alpha. we will form a right triangle. I'm going to call this point P. We've done this before, but I want us to do it again for what follows next. This measure is 1. Can anyone give us sine alpha? Of course, this, like any point on the Cartesian system, this is its y value, and this is its x value. So in other words, the coordinates of P are x comma y, and I would like us to identify cosine and sine. So for this picture, for this alpha, what would be sine? Y over 1, which means what? That's the reason why this piece is the same with sine alpha. This piece, this length is sine alpha. Can anyone give us what cosine alpha equals to in the unit circle? X over 1, which is x, which means this piece is nothing else but cosine alpha. That's the reason why, as you know, cosine is positive in these two quadrants and negative in these two quadrants. That's for cosine. And what about sine? So sine is positive at the top and negative in the denominator. I should say in the lower part of the circle. Okay, so cosine is measured on the x-axis, sine is measured on the y-axis. That's why sine is positive here and negative here, and cosine is positive here and negative here. So now I would like you to tell me from this unit circle and from this triangle with 1, and this is cosine alpha, and this is sine alpha, I would like you to write the Pythagorean theorem for me. The measure of this leg is sine alpha. The measure of this leg is cosine alpha, and I would like you to write, yes, Bailey?
Sine, cosine squared.
That's it. So this is indeed one of the most important identities in trig. That sine squared plus cosine squared of any angle, but the same angle. So if you write sine squared of pi over 6 plus cosine squared pi over 6 is 1. Sine squared of pi over 2 plus cosine squared of pi over 2 is 1. As long as the two angles are the same. Now I would like us to discover 2 more trig identities. This is the most important one. I would like you to divide both sides here by cosine squared alpha. And tell me what we get. So sine squared over cosine squared is? Very good. Tangent squared plus. Cosine squared over cosine squared is? And 1 over cosine squared, it starts with c, secant squared. This is the second most important trig identity. Now I would like you to divide the original one by sine squared. And we determine the third one, the third most important trig identity. So please divide. Yes? Plus? Yes? Very good. So now, do we have to memorize these? I don't want you to memorize the last two, because once you know the first one, you can come up with. But what I would like you to remember, which is very important, and you will see what happens in calculus when we get to the derivatives. They're all related. They're all related. And here's how they are related. Tangent with secant are related in the same equation. So keep that in mind. And cotangent and cosecant are related, and they are in the same equation. And you'll see how they are related further in the next step. So tangent with secant are together, and cotangent with cosecant are together. Any questions? I would like to go back to the unit circle for a moment and identify now. I know that each point on the unit circle, we already know that this is P of x comma y. But also, what does x equal to? We just determined a minute ago. Instead of x, I should write x and I should write y. Instead, I would write, no, it's the reverse. What is x? What does x equal to? No, for any point. Yes, this is cosine alpha, and this is, yes, we just determined them a minute ago. Right? We wrote that y is the same with sine, and we wrote that x is the same with cosine. Which means that at any point on the unit circle, can anyone give us, let's say this is B, can anyone give us the coordinates, the angle is beta, the coordinates of point B? Identical, but referring to the angle. Please. No signs. No signs. We have not determined anything. Just give me the point. Cosine beta, sine beta. Okay, so let's try one more time. We are not asked to determine those numbers. I'm just telling you what they will be. We don't have the angle. You can't say anything yet. You may say that both results here will be a negative number. Yes, you can say that. But you cannot put negative in front. If you put negative in front and this is a negative number, then it's all of a sudden it's positive. I'm only trying to establish at this point that any point on the unit circle, any point, has its first coordinate, the cosine of that angle, and its second coordinate, or the y coordinate, the sine of that angle. That's what I'm trying to establish at this point. So let's say this is angle gamma. Please give me the coordinates. You don't know anything about gamma. We're not determining anything here. We're just establishing what is the first coordinate of A. Right, that's all I want you to say this time. And sine gamma, whatever the numbers will be, we're not asked to determine them. And now I would like to establish what we call the corners, or maybe I call the corners. Now we can. So can you give me the coordinate of this point? So remember, this is a unit circle. Yes, so this point is, no, 1, 0, very good. What are the coordinates of this point? Excellent. The coordinates of this point, and the coordinates of this point. Excellent. Okay, now stay with me, please. I'm asking you to determine cosine pi. First coordinate of this point. -1. Okay, I'm asking you to determine sine pi over 2. Right, it's the second coordinate of that point. I'm asking cosine 3 pi over 2. Right, it's the first coordinate of this point. I'm asking sine 2 pi. Right, it's the second coordinate of this point. The point I'm making is you don't need to remember this. Because you will always know that on a unit circle, this is 1, 0, this is -1, 0, this is 0, -1, that's 0, 1. You don't have to put them in any table and sit there and say, oh, this is, no, there is no need for that. What if I ask you, find tangent of 0? You'll say, oops, wait a second. Tangent 0 is sine 0 over cosine 0. Sine 0 is cosine 0. So what is tangent 0? Excellent. What if I ask cotangent 0?
25?
Exactly. Because cotangent 0 will be cosine over sine, and since sine is 0, cotangent 0 is undefined. Yes, we can fill out the table, and we will. but there is no need to sit down and memorize it. That's all the point I'm making. So let's fill out the table for these. Because that's important. Because we're going to end up graphing these functions. So the complete table will be this. Please don't waste your time memorizing this. So 0 degrees and 0 radians. Pi over 6, 30 degrees. Pi over 4, 45 degrees. Pi over 3, 60 degrees. Pi over 2, 90 degrees. Pi, 180 degrees. 3 pi over 2, 270 degrees. 2 pi, or 360 degrees. At the top, sine, cosine, tangent, cotangent, secant, cosecant. Okay, sine 0 again. Perfect, cosine 0. So then tangent is 0, but this is undefined. And secant is 1 over cosine, which is 1. But cosecant is 1 over sine, which is undefined. I'm filling this table together with you, but I don't want you to memorize any of this other than those 3 numbers. And the points on the unit circle, which you know anyway. So this is 1/2, and this is the square root of 3 over 2. When we divide 1/2 by the square root of 3 over 2, we get the square root of 3 over 3 rationalized. Now cotangent would be this one reversed, which is the square root of 3. Secant would be 1 over cosine, which is 2 the square root of 3 over 3. And cosecant is 1 over sine, which is 2. For pi over 3, I'm just going to reverse everything. I'm not going to calculate anything. So this is the square root of 3 over 2. This is 1/2. This is the square root of 3. This is the square root of 3 over 3. This is 2, and 2 the square root of 3 over 3. I just reversed these. Sine with cosine, tangent with cotangent, secant with cosecant. 45 is the nicest because it's the square root of 2 over 2, the square root of 2 over 2, and these are both 1 because it's this over this. And then this is the square root of 2, and this is the square root of 2. For 90, you already told me the sine is 1, cosine is 0. So then tangent is undefined, and this is 0, and secant is undefined, and this is a cosecant 1 over sine, which is 1. For 180, you already told me the sine is negative, I'm sorry, sine is 0, cosine is negative 1. So then everything here is reversed. So it's 0 over this, which is 0. This is undefined. Secant is 1 over cosine, which is negative 1. And cosecant is 1 over sine, which is undefined. For 2 pi, I'm going to copy the same thing from the top. It's the same with 0. So it's 0, 1, 0, undefined, 1, undefined. And for 3 pi over 2, sine is 0. Of course, not. Negative 1, 0. So negative 1, 0. And then they are reversed. So tangent is undefined. Cotangent is 0. Secant is 1 over cosine, undefined. And cosecant is 1 over sine, negative 1. No, absolutely not. You should never, ever remember more than this. This makes no sense to remember. Sit down and memorize. No. It's up to you. But you can determine these in a blink. So that's all I recommend what we looked at last time. I wanted to fill out the table with you because we're going to reference this when we go to graphing those functions. Okay, I would like us to, any questions, please? Any questions? Okay, so let's look at any of these example or problems. Let's choose one and then move on.